Yes, your neighbor might actually be a witch. I'm talking about the nice elderly woman living just across the street. The one that always gives you cookies. You think that I'm joking, that you do not have to worry about your neighbor performing witchcraft. But I have evidence. Well, during yesterday's thunderstorm, the lightning rod on her house was struck by lightning. Of course, this can be easily explained by the fact that the god of thunder, Thor, was angry about your neighbor performing witchcraft. He therefore simply threw a thunderbolt at her house. Or what do you think? That the air normally acts as an insulator between charged particles that for some reason wants to be evenly distributed in space, which is why an invisible force field is created that is so strong that a strand of plasma is created that is hotter than the surface of the sun and coincidentally hits exactly the piece of metal on your neighbor's roof because for some reason the energy transported by the lightning travels more easily through iron? Please, be realistic. This may be an abstract example, but having to decide between two hypotheses is actually very common, whether in science or in everyday life. Here is an example. Imagine you're trying to call your friend but he does not pick up. Maybe he lost his phone, or maybe he just forgot to charge it. The question arises, how do you decide between two hypotheses? One simple approach is provided by an old philosophical principle. It's called Occam's razor. It's a heuristic, a rule of thumb that indicates which of two hypotheses is preferable. The idea behind this principle is attributed to a 14th century monk named William of Occam. It's frequently cited as entia non sunt multiplicanda praeta necessitatem, which translates as entities must not be multiplied beyond necessity. The statement can be interpreted in different ways. I adhere to the following interpretation. First, of several possible sufficient explanations for one and the same state of affairs, the simplest theory is preferable to all others. Second, the simplicity of hypotheses is a desirable quality criterion. But let's start with the basics. Firstly, in philosophy, a razor is often understood as a metaphor that serves to shave away unnecessary assumptions. So, what does one cut away with Occam's razor? Essentially, it involves dispensing unnecessary beliefs when explaining phenomena. If two theories can explain the available evidence equally well, the simpler one should be preferred to the more complicated one. Here is an example. Nowadays, of course, we know that the Earth revolves around the Sun. But that wasn't always the case. Before, there was the so-called geocentric worldview. Scholars thought that the Sun revolves around the Earth. In the 16th century, Copernicus wondered whether the observations that led to the geocentric worldview could not be explained by a model that used fewer and simpler constructions. He came up with the heliocentric model, where the Earth revolves around the Sun. Copernicus' model could not necessarily make better predictions, but it did explain certain phenomena more simply. For example, there is the phenomenon that planets, which normally travel from east to west across the sky, occasionally reverse their direction of motion to travel west to east before reversing again. This apparent backward movement of planets is known as retrograde motion. Historically, to explain this with the geocentric model, astronomers used a complex system of episcles, smaller circles whose centers moved along larger orbits. However, episcles didn't explain the phenomenon. The heliocentric model ultimately showed that retrograde motion isn't a real reversal of direction, but rather an illusion of perspective. It happens when Earth passes another planet or is passed by it. This case is a good example for Occam's razor. Copernicus' much simpler heliocentric model turned out to be right. But be aware, Occam's razor does not cut away evidence. If we have a hypothesis that does not fit the available data, we have to reject it, no matter how simple it is. Occam's razor does one thing really well. It articulates an affinity for simplicity. The idea that simpler explanations are more preferable than complex ones. You might say this idea is obvious, but actually, it's not. How people perceive the world, their surroundings and make decisions is often not optimal. It's irrational, systematically distorted. These distortions are called biases. Investigations into these biases fill books, occupy researchers and are honored with the Nobel Prize. One of these biases is called the conjunction fallacy. It interferes with the very basic principles of probability. The probability of an event A can never be less than the probability of the event A and the event B. An example. The probability that Thomas likes tomatoes cannot be smaller than the probability that Thomas likes tomatoes and likes to go swimming. This is because the probability that he likes tomatoes and goes swimming is already included in the probability that he likes tomatoes. Here again graphically. The circles symbolize the probabilities. The probability for both events occurring is represented by the overlap of the circles. Logically, the overlap of the circles cannot be greater than the circles themselves. But this is exactly where people seem to have problems with. In a study from the 1980s, people were given following context. Linda is 31 years old, single, outspoken and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. The test subjects were then asked to state the probabilities of statements about Linda. It turns out that the statement, "Linda is a bank teller and is active in the feminist movement," was rated more likely than the statement, "Linda is a bank teller." This is simply illogical. In every case in which Linda is a feminist bank teller, she also is a bank teller. The probability of Linda being a feminist bank teller can therefore never be greater than the probability of Linda being a bank teller. Makes sense. Actually, people should sanction the more complicated assumptions in their world when making assessments. But how do you recognize simple versus complex assumptions? I referred to the example at the beginning. It sounds less complex that an angry god just threw a lightning bolt than the complex physical explanation for lightning. But that's deceptive. The pure length of an explanation does not describe the complexity of the statement made in it. In the 1960s, a US mathematician formalized the idea behind Occam's razor. His name was Ray Solomonoff. He proved that the best possible scientific explanation is the shortest algorithm that generates the empirical data under consideration. From here on, it would get very mathematical. For us at this point, the idea of measuring the complexity of hypotheses according to how complex an algorithm that simulates the available evidence would be is sufficient. This is a good strategy to become more aware of the individual parameters of a situation. Ask yourself, if you had to simulate the situation, how would you do it? Here is an example. You are at a party and you don't know that many people. You put your cup down and when you go to pick it up again, you see that it's missing. You wonder whether the host has deliberately removed your cup to signal that you are not welcome. You wonder whether you should leave. It would be difficult to create a computer program that simulates a passive-aggressive party host, who has a negative attitude towards you and wants to show you this through subtle hints. On the other hand, it would be easier to simulate that someone just happened to take your cup. This should be your preferred hypothesis. You should stay at the party and just get a new cup. We used Occam's razor to solve our problem because we simply opted for the simpler hypothesis. Because it was simpler. But as it is in philosophy, Occam's razor is sometimes criticized. There is even a counter-sentence in medicine called Hickham's Dictum. Hickham's Dictum is a principle in medicine which states that patients can have several coexisting diseases at the same time. It serves as a warning against relying too much on Occam's razor when diagnosing diseases. As in medicine, one should be careful when using Occam's razor in everyday life. The simplest explanation can, of course, be wrong, but often it's not. Thanks for watching.